Question 2. A curve C has the equation y equals x squared minus 2x minus 24 root x, where x is greater than 0. Find dy dx. So the first thing we're going to do is we're going to write out our equation y equals x squared minus 2x minus 24, but in power form, so x to the half. And then to differentiate this, dy dx, x squared will go to 2x, minus 2x differentiates to 2, and then we've got minus 12x to the negative a half. Part 2, so that's our answer. Find d squared y dx squared, d squared y dx squared. So we just differentiate our differential. 2x will differentiate to 2, minus 2 disappears, and then we've got minus a half times minus 12 is plus 6x to the minus 3 over 2. So there. Part B, verify that C has a stationary point when x is equal to 4. So a stationary point is where dy dx will equal 0. So what we can say is we've got 0 is equal to 2x, take away 2, minus 12x to the minus a half. So what we know is that if we sub in x equals 4, that should be true. So let's give it a check. So 2 lots of 4, take away 2, take away 12, lots of 4 to the minus a half. And plugging that into the calculator, we get a value of 0. So as we know, dy dx is equal to 0, therefore there is a stationary point. Part C, determine the nature of this stationary point, giving a reason for your answer. So we know that the stationary point is at x equals 4. To determine the nature, we have to plug this value into d squared y dx squared and look at the sign of the answer, positive or negative. So we've got d squared y dx squared is equal to 2 add 6 lots of 4 to the minus 3 over 2. And so this is going to be 2 add 3/4. And so it works out as 11 over 4. And now as 11 over 4 is greater than 0, this means x equals 4 is a minimum value, or a minimum point.